Hello, dear students. Today we are going to study stoichiometry. Stoichiometry makes possible to do calculations from mole to mole, grams to mole to mole, grams to mole to mole to grams. We can calculate the limiting reactant and also the theoretical and the percent yield. Let's begin. The first thing that we have to do in order to do any type of calculation is to have a balanced chemical equation. For example, we have A plus B that produces AB2. As you can see, this equation is not balanced. We have to put a 2 in front of here, and then the equation is already balanced. What is the meaning of the coefficients? Remember, we have here a number 1, even though we don't write it, and also here. Then these numbers in front of the substances, the coefficients, represents the molecules or the moles of the substance that are reacting in this chemical equation. Then the ratio of A to B to AB2 is 1 to 2 to 1. What does it mean? Well, let me tell you. For example, if we have 3 moles of A, and I want to know how many moles of AB2 I can produce, I can use the ratios. You know that 1 mole of A produces 1 mole of AB2. Then you write down 1 mole of A. Why do you write A down? In such a way that I can cancel moles of A with mole of A. Because this is what is given. And what do you need to know? What you are asked for? Well, about the moles of AB2. Then you type here 1 mole of AB2. And when you do the calculations, you get that the answer is 3 moles of AB2. Well, this is what I say is the main thing of this type of calculation. Also, we are going to calculate the molar mass because we can say that, for example, hydrogen, the atomic mass of hydrogen is 1, and the atomic mass of chlorine is 35.5. Then at all, the atomic mass of hydrochloric acid is 36.5 grams per mole. For example, suppose that the molar mass of AB2 is 60 grams. Then you write 60 grams is 1 mole of AB2. So in this case, you cancel moles of AB2 with mole of AB2, and you multiply, and you get that the answer is that 3 moles of AB2 is 180 grams of AB2. Then here you have the two types of calculations that you can do in stoichiometry. They are the main ones. First, going from mole to mole. And now going from mole to grams. Let's see the first example. For example, you have that this compound that is known methane reacts, 1 mole of methane reacts with 2 moles of dioxin and produces 1 mole of carbon dioxide and 2 moles of water. So the ratio is 1 to 2 to 1 to 2. This is the ratio, or these are the ratios in this equation. For example, you have to see that the equation is already balanced. If not, everything is wrong. Knowing the ratios between methane and dioxin, methane and carbon dioxide, and methane and water, you can do any type of calculation. For example, you have 2 moles of methane. That is what is given. And you begin the calculation by what is given. And then the question is, how many moles of dioxin do you need? Then you have to write the moles of dioxin up and the moles of methane down. From the ratios, you can see that 1 mole of methane reacts with 2 moles of dioxin. Then the ratio will be 1 to 2. Sorry, the opposite. The opposite. Then it will be 1 of methane per 2 of dioxin. That's why I write here this conversion factor. Remember that we are using dimensional analysis. If you have any doubt about this type of calculation, try to go back and see what we have explained about dimensional analysis that was studied in chapter 2. So, why do you write mole of methane down in such a way that you can cancel given with given? And in the upper part, you have what you are asked for, the question. So you multiply 2 times 2 divided by 1, and it gave you 4 moles of what? Of dioxin. Because you cancel mole of methane with mole of methane. This is the simple calculation where we use the mole ratios. And we can do it with carbon dioxide, with water, with any of the reactants or products in a chemical equation. Here you have another example. You want to know what is given. 3 moles of dioxin. This is what is given. Then you write here what is given. And you want to know the moles of water, of course. Moles of water is going to go up and moles of dioxin down. According with the equation, you know that 2 moles of water, 2 moles of water are produced from 2 moles of oxygen. Then the ratio is 2 to 2. That's why I use this conversion factor here in such a way that I can cancel this with this, and then what you get? What you are asked for, moles of water. 3 times 2 divided by 2 give you 3 moles of water. You can stop the video at any time and try to do it by yourself. It's the only way you can understand it perfect. Now consider the reaction between hydrogen and oxygen to produce water. In this case, the ratio is 2 moles of dihydrogen reacts with 1 mole of dioxygen and produces 2 moles of water. Then the ratio is 2 to 1 to 2. Then, what is given in this case? 10 grams of dihydrogen. And you want to calculate the moles of dihydrogen. How can you do that? Well, you know that mole is equal to grams, the mass in grams, divided by the molar mass. This is mass in gram divided by the molar mass that is given in grams per mole. Everybody knows how to calculate the molar mass of any substance. In this case, the molar mass, or the mass, sorry, let's begin by what is given, 10 grams of dihydrogen, and you know that the molar mass of dihydrogen is 2, because every atom of hydrogen is 1, so you have to, then the molar mass of dihydrogen is 2 grams per mole. Then you cancel grams with grams, and the answer will be in moles. 10 times divided by 5 by 2 give you 5 moles of dihydrogen. This is the answer. But the question is more than this. We want to calculate the grams of water that are produced. So let's continue. Well, as I showed you before, you divide the mass of dihydrogen by the molar mass of dihydrogen, and you get the moles of dihydrogen. It's more or less 5 grams, 5 moles, as I showed you before. But here is more accurate the calculation. Let's go. Now, we have the chemical equation. We have the chemical equation between hydrochloric acid and sodium hydroxide to produce sodium chloride and water. As you can see, this equation is already balanced. Then we want to calculate the grams of sodium chloride that are produced from 2 grams of hydrochloric acid. What I'm going to do, first we have to calculate the molar mass of hydrochloric acid and the molar mass of sodium chloride. And from the equation, we can see that 1 mole of hydrochloric acid produces 1 mole of sodium chloride. So, we begin by what is given. Mass of hydrochloric acid. Then I use the molar mass of hydrochloric acid to convert grams, that is what is given, into moles of hydrochloric acid. And later, using the ratio, we can calculate the moles of sodium chloride. But the question is not moles. We want to know the mass of sodium chloride. So we use the mass, the molar mass of sodium chloride that we calculated before, and we can cancel moles of sodium chloride with mole of sodium chloride. And when we do all this calculation, we see that the mass will be in grams of sodium chloride. That is the question. 3.21 grams of sodium chloride. You can stop the video. This example, it has all the types of calculation that we need to know. If you understand it, you can follow this pattern to do any other type of calculation. So here you have that from 2 grams of hydrochloric acid, you can get 3 times 21 grams of sodium chloride. Well, here we have gasoline. When gasoline reacts with oxygen, you produce carbon dioxide and water. The question is already balanced. So we want to know first how many moles of gasoline you have from 1,000 kilograms of octane. Octane is gasoline. So first you convert kilograms into grams. That is 1 million grams. And then you divide by the molar mass of gas of octane. As you know, you have 8 carbon plus 18 hydrogen, and you get that the molar mass is 114.26 grams per mole. Then you divide grams per molar mass, and you get the number of moles of octane that you have in this reaction. But suppose that you have two moles of octane, of gasoline, produce 18 moles of carbon dioxide. You can simplify this ratio 1 to 16 to 1 to 8. So you see that if you have this number of mole of octane, you can produce this number times 8, because the ratio is 1 to 8, and you get the moles of carbon dioxide that can be produced from this number of moles of octane. Stop the video, try to do it by yourself in order that you can understand. The only way to understand this type of calculation is trying to do it by yourselves. But the question was not the number of moles of carbon dioxide. We need to know the mass of carbon dioxide. So we multiply by the molar mass. You cancel moles with moles, and then you get the answer in grams. And this is the amount in grams of carbon dioxide that you produce and goes to the environment and produce this in the increasing of the temperature in Earth, as you know, from 1,000 kilogram of octane or gasoline that is burned. And this is a reaction that happens in your cars. It's also the reaction that is produced in any type of a combustion where you have a gasoline burning? Well, this is the answer. You can produce 3,080 kilograms of carbon dioxide every time you burn 1,000 kilograms of octane. But now I'm going to show you how you can do all the calculations using only one formula. Then what is given? The mass of octane. Then you multiply by the molar mass in such a way that you can cancel grams with grams. And then you use the ratio in the equation to get moles of carbon dioxide. And later you multiply by the molar mass of carbon dioxide in such a way that you get grams of carbon dioxide. Look, doing this way, you can do all the calculation in one step. Before I show you how to do it step by step, but I recommend you, strongly recommend you to use dimensional analysis to do these calculations, because this way you don't round up in between. You round up only at the end and you get the correct answer. If you do it step by step and you round up in between, you get a wrong answer at the end. Well, here is the way you can convert grams into kilograms divided by 1,000. You convert grams into kilograms. And this is the this is the answer that you have to give in this problem. Well. Let's calculate the amount of carbon dioxide that can be produced when you burn 2.3 grams of methane. And this methane reacts with 3 grams of dioxin. Well, in this case, you have the mass of one of the reactants and the mass of the other reactants. When the mass of the two reactants is given, you have to begin by doing the calculation for every one of them in a separate way. We begin first from 2.3 grams of methane and from 3.0 grams of dioxin. Well, you can see here that the molar mass of methane is 12 plus 4 is 16 grams per mole. You can calculate it. And you know that oxygen is 16, but in this case you have 2 oxygen, then it will be 32 grams per mole. Then what you have to do in this case? Well, you say 1 mole of methane is 16 grams of methane. In this case, you say, oh, 1 mole of dioxin is 32 grams of dioxin. In this way, you can cancel grams with grams and grams with grams, and you have the answer now in moles of methane and moles of dioxin. Later, you do the calculation from mole to mole using the ratios in the question. Okay, down you write moles of methane. As you can see here, you have 1 mole of methane, and the question is about the amount of carbon dioxide. Then you have to watch carbon dioxide. There is only one here. Then you say 1 mole of methane produce 1 mole of carbon dioxide. Now you cancel mole of methane with mole of methane, and the answer until here is in mole of carbon dioxide. But you're not interested in mole of carbon dioxide. You are interested in grams of carbon dioxide. So carbon is 12, and you have 2 oxygen, and 2 oxygen is 16 times 2 is 32. Then the molar mass of methane is 44, sorry, 44 grams of carbon dioxide in 1 mole of carbon dioxide. Then you cancel mole of carbon dioxide with mole of carbon dioxide, and you will get here the answer. In this case, you say, well, the ratio between moles of O2 and moles of CO2, you go to the question, you say, oh, 2 moles of dioxin produce 1 mole of carbon dioxide, in such a way that you can cancel this with this, and later, using the molar mass of carbon dioxide, you can calculate the grams of carbon dioxide that can be produced from 3 grams of dioxin. Then now we have to do the calculations. I already did the calculations, and you can stop the video if you want. I made it step by step, and later I calculate that I can produce uh, from the mass of dioxin, I can produce this amount of carbon dioxide, and from the mass of methane, sorry, we can produce this mass of carbon dioxide. Now, at this step, you compare these two amounts. What happened? Oh, this is small. So what does it mean that when the mass of dioxin is over, you have a still certain amount of carbon dioxide of methane that didn't react yet. But this is an excess, so we cannot take into account this number. We can produce only a small amount because oxygen is the limiting reactant, and at the same time, we can say that the amount of carbon dioxide that we can produce from the amount of dioxin, this is also then oxygen is the limiting reactant, and 2.068 grams of carbon dioxide is the theoretical yield. What does it mean? Well, using calculations, we can calculate that this mass of carbon dioxide could be produced. In the real life, sometimes it is not possible because the temperature, the pressure, and many other factors are not good enough, and then we don't get this amount of carbon dioxide in real life. That's why we have another thing that is known as percent yield. Suppose that in the real life you get only 1.9 and not the amount that you calculated. Then you divide actual yield, that is the amount that is obtained in the real life, but the one that you calculated, that is the theoretical yield, and you multiply by 100 and you get that the percent yield is 91.88%. Well, I know that there are, or you have a lot of calculations here, and maybe they are a little confusing, but I recommend you to watch the video many times. Then you stop the video when you have the first problem, and then you try to do it by yourself, and so on. The only way to learn how to make a stoichiometric calculations is by doing stoichiometric calculations. See you soon.